Hi, now here we have a question on using the interval bisection method to estimate a root of an equation. And if you're unsure of this, you can always check out my website ExamSolutions.net, where you'll find tutorials on this. Well, for this example, we've got to show that f of x equals x to the power 4 plus x minus 1 has a real root alpha in the interval 0.5 to 1. And then we've got to start with this interval 0.5 to 1 and use the interval bisection method twice to find an interval of width 0.125 which contains alpha. So if you haven't tried this question already, just pause the video, come back when ready, and I'll take you through the work solution. Okay, welcome back if you had a go. So what we've got to do is check out to see whether there is a change in sign over the interval 0.5 to 1, because basically what's happening is that if we have a graph where we've got the x-axis and the y-axis, and we take this interval 0.5 and 1, this is not drawn to scale, okay, we would expect that the graph would go from, say, a negative to a positive value, or a positive to a negative value. And if it does that, and assuming the curve is continuous, which it is over this interval, we would expect to see a root somewhere then in this interval here. So all we've got to do then is just work out what f of 0.5 is, and similarly what f of 1.0 is. Well, if you put 0.5 through here, you'll find that you end up with a negative value, minus 0.4375. And if you put 1 through here, you could do that in your head, it just turns out to be 1. So you can see that what we've got is a change in sign. The curve then has gone from a negative value at 0.5, let's just say that's down there, up to a positive value of 1 at 1. So the curve has crossed through this interval at some point. I don't know exactly where it is. I mean, that's going to be the part that we're going to work with in part B. But for the moment though, we do need to say that with these results, just summarize by saying that a root lies in this interval since there is a change in sign and f of x is continuous over this interval. Okay? Right, well that's part A then. Now in part B, we're told that starting with the interval 0.5 to 1, we've got to use the interval bisection twice to find an interval of width 0.125 which contains this root alpha. So first of all, what do I know? Well, I'm going to cut this interval in half, okay? I'm going to let's just draw a little sketch down here, say, okay, what's going on. It might help simplify things a bit. Okay, we've got x and we've got y. We're taking the interval 0.5 and 1 again, and we're cutting this in half. So cutting this in half is going to be the value 0.75. So just put 0.75 in there. And so what we want to do is find out what f of 0.75 is going to give us. Is it going to give us a positive value or a negative value? And by that we'll be able to determine which interval, whether it's this interval or this interval, that the root lies. So if we do f of 0.75, put x is 0.75 in here, work it out, what you find you get is 0.06640 and so on. So a positive value. So that's telling us then that we know that we had a negative value at 0.5, we've now got a positive value at 0.75, so the curve must have come up through here, positive value at 0.75, carried on, okay? So our root then lies in this interval from 0.5 now to 0.75. So what we're going to do now is just check out what happens when we bisect the interval from 0.5 to 0.75. So I'm going to just enlarge this a bit just so that we can view it. And if I work out the midpoint of these two, just add the two values together, 0.5 and 0.75, and divide that answer by 2, you'll get your midpoint value there. And it turns out to be 0.625. So we'll just come down here a bit further, put 0.625 there. Okay? So we just need to do 0.625 for x, f of 0.625. What do we get? Well, if you put that through your calculator, you end up with a negative value, minus 0.2224, and so on. So that means that we had a negative value at 0.5, we still got a negative value at 0.625, but a positive value at 0.75. So the curve must be coming up something like this through here. So we've got our estimate of our root, that it lies in this interval here. Let's just say that's our root alpha. Let's put it in there, and that is our estimate. And you can see that it is in an interval of width 0.125. The difference between 0.75 and 0.625 is a width of 0.125. Okay, so I hope that's given you an idea then on how we can apply the bisection method then twice over.